Okay, in this video we're talking about the 7 different types of indeterminate forms you're going to deal with in calculus and when using L'Hopital's rule. So I've broken them up into 3 different categories, and this first category is the one that comes up the most, and it's the one that's easiest to deal with, because when you get 0 over 0 or infinity over infinity, immediately you can just do L'Hopital's rule. Okay, if you haven't seen L'Hopital's rule, go ahead and check out my video on it. It should be somewhere really close. So for example, if you had the limit as x goes to 0 of x squared minus x over, I don't know, x cubed plus x, I don't know. That would be a case where you're going to get 0 over 0, and you can immediately jump to L'Hopital's rule. Or you could have something where limit's going to infinity, and I could actually just use the same example here. X squared minus x over x cubed plus x, and then you would get infinity over infinity, and immediately you would just use and apply L'Hopital's rule. So 0 over 0 or infinity over infinity, those are the easiest cases because you can just immediately use L'Hopital's rule. The second category is just a little more difficult, and basically you're gonna transform 0 times infinity or infinity minus infinity into one of these. Okay, so your goal is to transform the second category into the first category. So let me show you an example of something that would look like that. So let's just say you had x going to 0 from the right of x times ln x. If I plug in 0, that would be 0, and then log of 0, or the natural log as we approach 0 from the right, actually goes down to minus infinity. So you have 0 times minus infinity, and the question is, well, is x going to 0 faster, or is ln x going to minus infinity faster? So that's why it's indeterminate. We don't quite know, but the strategy is you write this as a fraction. Okay, so you've got this function times this function, and all you do is, instead of writing times the first function, you write 1 over that function. And these are completely equivalent statements. But now the thing is, if I plug in 0, I'm getting negative infinity, and now 1 over 0 is infinity. I'm back at stage 1. I can just do L'Hopital's rule. So whenever you see 0 times infinity, you write it as a fraction by writing 1 over one of the functions. The other thing that can happen, and it's a little less common, is infinity minus infinity. Let's say you had the limit as x goes to 0 of 1 over x minus 1 over sine x. And if I evaluate this thing at 0, I'm going to get 1 over 0 minus 1 over 0. 1 over 0 approaches infinity. 1 over 0 approaches infinity. And the question is this infinity bigger or is this infinity bigger? So that's why it's indeterminate. And so your strategy for this is to combine these two things somehow. You want to make it a single fraction instead of 2 different fractions. So you could just combine these 2 fractions by saying cross multiplying. 1 times sine is sine minus sine in the middle. X times 1 is x, and then you multiply the denominators together. Voila, you've combined those 2 fractions, and now if I plug in 0, sine of 0 is 0, minus 0 is 0, and I'll get a 0 on the bottom. And hey, look at that. I'm in stage 1 again, and then I can immediately jump L'Hopital's rule. Okay? All of these are just transforming back to step 1. And again, if I'm going too fast, please just give me a pause, rewind, watch the video again. Stage 3, this is the hardest. This is when you have 0 to the 0, or 1 to the infinity, or infinity to the 0. So here's an example of something when that would happen. If you had limit as x goes to 0 from the right of x to the x. I actually made a video about this very problem. It's a really common question asked, so I have a video on this problem. I'm not going to go through it right here, but if you want to see this problem done, you can check it out. I've got it on my channel. If I evaluate this, I plug in 0 for x, I have 0 to the 0. That's an indeterminate form. So what we do with all of these is we do this trick where we do e to the ln. I'm taking advantage of the property of logarithms that said if I have e to the log, I can cancel those and just get what's on the inside. Well, if I can go from right to left, I can go from left to right. So I haven't done anything wrong here. It's just I've kind of like multiplied by 1 in a sense. So that's why I'm allowed to do this. But now I take advantage of another property of logarithms that says if I have the log of something to a power, I can write it as the coefficient. It's not the power rule, it's just a property of logarithms. Now if I plug in 0 from the right, I'll get e to the 0. Remember we just said log of 0 is negative infinity. Hey, look what happened. We got moved into category 2. We got 0 times infinity. What did we do when this happened? Well, we wrote it as a fraction to make it into stage 1. So what you do from here is you write this like e to the log of 1 over x. And now if I evaluate at 0, I get log of negative infinity over 1 over 0, which is infinity. You're in stage 1, just like last time. And then you'll use LHR just in the exponent of e. So all of your answers are going to be e to something in this third category. 1 to the 0, or I'm sorry, 1 to the infinity and 0 to the infinity, they don't come up as much, but they're the same thing. You're going to do this e and ln trick and then bring down the power. You'll be in stage 2 and then write it like a fraction and you'll be in stage 1. Those are the 7 different indeterminate forms. I don't personally know if there are any others that you're going to see in calculus, but those are the most common for sure. If you can do these, you can do just about any limit problem in the world. So there you go. I hope you got something out of it. If you want to see more indeterminate form videos, please let me know. I'm always wondering what you guys want to see me do. And please like, comment, and subscribe. I put out new videos just about every single day. Okay, have a great day, and thanks for watching.